Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, for today's M&Ms, representations of portions, this is where you get into your notes. If you don't already have it written in from our lessons, uh, it's kind of a triangular sort of a shape, which shows how you can go from a fraction to an equivalent decimal to an equivalent percent and back and forth between them. And of course, you can do a visual representation or write out the name of the number in words. So if you take 4/5 and you want to draw a picture of it, you can do that, drawing 4 balls or circles, and then you shade in, or 5 of them, and you shade in 4 out of the 5. Sometimes this gets a little confusing, to be honest with you. I would almost rather draw a circle like this and then shade in 4 of the 5 parts. 1, 2, 3, 4 out of the 5. Because, some people might look at that as 1, 2, 3, 4. Well, this is one where it actually gets confusing. Is this supposed to be 3/4 or 1.5? It gets kind of confusing where every circle is considered a whole. Then since this one was cut into a half, then we can cut that in half. And so technically this isn't 3/4, this is 3/2, right? 1, 2, 3/2 have been shaded in. So this can get a little bit confusing with how we draw the visuals. I would prefer that we just focus on going from fractions to decimals to percents. And the process for going from a fraction to a decimal is doing the division problem. Hold on for a second. 3 divided by 5, 5 goes into 3 0 times. At a decimal point, 5 goes into 36 times, so you get 6/10. And we can take 6/10 and change it to a percent by multiplying this times 100. Or you can take the 3/5 and think, what would I multiply times 5 to give me 100? That would be 20. So we multiply 3 times 20 and we get 60. And by definition, by rule, 60 hundredths means 60%. Okay? So just keep in mind, all rational numbers, that would be numbers that are written as either fractions or decimals, can be written as fractions, decimals, or equivalent percents. All right, so number 45 is about recognizing patterns. So copy the rows of equations below and write what you predict will be the next 5 rows in the sequence. So each one of these increases by a digit, and the next digit is the next number in the sequence. These quantities are always being multiplied times 9, and then at the end, whatever number is one more than this multiple here gets added on. So this is one more than the 2 is the 3, one more than the 3 is the 4, one more than the 4 is the 5. Why anyone would figure this pattern out is beyond me. But it is a pattern, and this is meant to illustrate that if you can see a pattern in mathematics, you often can solve problems very easily mentally without having to go through the process of doing all the work. I mean, can you imagine going through and multiplying all of this times 9, then adding 9 to it to get this as your answer? So there you go. Seeing patterns in mathematics is very good. It's very helpful. All right. And here we get to some of those visuals that are often creating problems. Here are 4 circles, and one of the 4 are shaded in. So this represents 1 out of 4, or 1/4. This is the one that confuses people. This is one whole triangle, and this is another half of a triangle that's got stripes on it. So 1.5 is the same as 150%. And then here, 2/3, 2 out of the 3, that's usually pretty simple. And knowing that 2/3 is the same as 66.6 repeated, or you could have said 66 and 2/3 percent. That would be another way to write this in percent form. Now going in the other direction, 2/3, well, that's what we just had on the previous page, right? 1 1/8 means we're going to take one complete circle and 1/8 of another circle. And then 6/9 technically is the same as 2/3, right? If you think there's 1/3, 2/3, 3/3, but it's an equivalent fraction. So we would create a rectangle that is 9 equal parts, and then 6 of the 9 equal parts are shaded in. 5 notebooks cost $5.25. So how much would 3 notebooks cost? Okay, proportional reasoning. How do I know this is proportional reasoning? Because if you don't buy any notebooks, you're not going to spend any money, right? So 0, 0 applies. And you know that each one of these notebooks should have a constant unit rate. And so if you chose to find the unit rate and use that to help us solve the problem, you could. So 5 of them cost $5.25. So that means that each one of these would have to cost $1.05. So that would be the unit rate. $1.05 per notebook. So now you multiply that times 3, and that's how you get your $3.15 for 3 notebooks. So whether you choose to look for a giant 1 or use the unit rate, either one is fine. But I would say this problem is kind of complicated if you're looking for a giant 1. That's one of the reasons why we use different strategies depending on the nature of the problem and the numbers presented. It might be better to use the unit rate in this situation compared to other situations where it was easy to find the giant 1. So you just have to make that choice of which way you like better and use that way. Now, there is a third way to solve this problem, which a lot of students like to use, and that is called using cross multiplication. This involves some algebraic reasoning where I would multiply these numbers across from each other. So 5 times x is 5x, and $5.25 times 3 is $15.75. So what number do you multiply times 5 to give you $15.75? Well, if we take 1575 and divide by 5, that will give us that number. Stop it. Why? Oh, I multiplied. Sorry, hold on. 15.75 divided by 5. There it is, right there. Okay, so 3 different approaches for solving proportions, whichever way makes most sense to you. I've had students in the past that exclusively do the cross multiplication because it works every time. And of course, they use their calculators to help along the way. All right, and more perimeter and area. Knowing formulas is really important. This is a triangle here, so we're going to take 1/2 times the base times the height. So 1/2 times the base times the height, half the base would be 6, and the height would be 4, so 6 times 4 is 24. Adding the 3 side lengths is generally pretty straightforward for finding perimeter. Same thing here, just add those 4 numbers together, you get that. But the formula for the trapezoid gets a little bit trickier. You have to take the average of these 2 bases. So base 1 is 8, base 2 is 15.5, and then multiply times 4. And one of the things I like about writing it this way, where the 1/2 is being multiplied times this quantity, which is being multiplied times the 4, is that I don't necessarily like taking taking half of what would that be, 23.5. I don't want to take half of that. So I'm going to use commutative property, and I'm going to take half of 4. Half of 4 is 2. So this is going to be 2 times 23.5, which is how you get your 47. Okay? If I did that a little quickly and you need me to go over it again, I'd be happy to. I'd recommend first that you back up the video and rewatch what I just did there. If you want to take half of the 23.5 and take that answer and multiply it times 4, you'll still get 47 square inches. This way, I was able to do it mentally without having to use a calculator or show any work. And so using these different mathematical properties like commutative property to help us solve problems. That's our goal, right? That's why we learn these problems. All right, I think that does it for today's homework. How long did that take? 10 minutes. All right, I'm signing off. Take care. Bye.
Hey, feeling good, like I should. Winning